Chemical properties of S block elements. Yesterday we have learned about the physical properties, that what are the physical properties, how you can identify that which metal is this, है ना? What is the color of the metal, what is the physical state of that metal of alkali elements. Okay, so today we'll continue our class with the chemical properties of S block elements. The alkali metals are highly reactive due to their large size and low ionization enthalpy. Okay, these are considered to be the highly reactive elements of the periodic table. They react vigorously among all the metals. They just react vigorously when come in exposed to air, water, and other things, right? The reactivity of these elements increases down the group. The highly reactive is lithium, then sodium, then potassium, then rubidium, and then cesium. Okay, now first we'll learn the reaction with air, how these elements, alkali metals, react with the air. So on exposure to moist air, the surface get tarnished due to the formation of their oxide, hydroxide, and carbonates. Right? When means we know this thing that air is the mixture of gases. There are a large amount or so many gases, a number of gases mixed in the air. A part of that oxygen, carbon dioxide, and the moisture. Okay, the amount of these three is maximum in the air, with which these metals react easily. So with whenever the sodium react with oxygen, it forms N2O, and this N2O when react with water form NaOH, that is base sodium hydroxide, and that sodium hydroxide when react with the CO2, it form N2CO3H2O. N2C and Na2CO3 is the baking soda, and baking powder is NaHCO3. When you will obtain what, the baking soda and water, so hence they are capped under inert liquids like kerosene oil, but lithium is capped wrapped in the paraffin wax because it floats on the surface of the kerosene oil due to its low density. So that is why, due to the reactivity towards the air, we used to keep the sodium and potassium into the kerosene oil dipped into the oil, because it does not react with the oil, it reacts with air, the components of air. And lithium we used to wrap into paraffin wax. Paraffin wax is the product of petroleum. Okay, the wax, the candles which we used to use, the paraffin wax is used to make candles, the jellies, petroleum jelly, that is paraffin wax. So we used to wrap the lithium inside the paraffin wax, because if you just put the lithium into the kerosene oil, it get float over the surface. Why? Because of its low density. And the sodium and potassium, because of high density, they just sink into the oil and can be kept dipped inside it. Note, fire due to the alkali metal is extinguished by CCl4. Okay, if any time you just take out these metal out of the oil and paraffin wax, they just burn with a flame when come in exposed to the atmospheric air, and this air can be extinguished by CCl4. Reactivity towards oxygen. All alkali metals, when heat with oxygen, form different types of oxides. Lithium form lithium oxide, Li2O. Sodium forms sodium peroxide, and rubidium, cesium, and potassium form superoxide, MO2. Okay, M is the metal. So you can say that alkali metals, whenever react, they just form oxides, peroxides, and superoxides, right? The stability of peroxides and superoxides increase as the size of alkali metals increases. The superoxide O negative ion is stable only in the presence of large cations. If you say that the superoxides can be formed by the large cations, that is potassium, rubidium, and cesium. So when Li react with oxygen, it forms Li2O, that is oxide. Sodium react with oxygen, it forms Na2O2, that is peroxide. And these M metals, for example, K react with the oxygen, forms KO2. Rubidium react with RbO2, and cesium react with oxygen and form what? Cesium oxide, right? So in all these oxides, the oxidation state of the alkali metal will be +1, because they have a one unpaired electron with they can form bond or they can share, and the property of metals is to donate the electron. So that is why the oxidation number of the alkali metals will be plus 1, right? So because of their high reactivity towards the air and water, these alkali metals are normally kept into the kerosene oil, and lithium being highly reactive and low density, we used to keep it inside the paraffin wax, wrapped inside the paraffin wax, so that it will not react with the atmospheric air or other gases which is present in air, right? Next is reactivity towards the water. Alkali metals react with water and their compounds containing acidic hydrogen atom, such as like hydrogen halides, acetylene, and it's just liberate out the hydrogen. So whenever the these alkali metals react with the water, the hydrogen get liberate out, and the OH negative will react with the metals and forms hydroxide. For example, the alkali metal react with water to form hydroxide and dihydrogen. Dihydrogen will liberate out. And if you want to identify that which gas is liberating out, you just put a matchstick over the test tube. It will burn with a pop-up sound, which indicates that that gas is hydrogen, H2, right? Lithium, due to its small size and very high hydration energy, does not react with the water because its hydration energy is high. So it do not react with the water vigorously, even though has most the E value, right? But on the other hand, sodium do not react with water vigorously, even though it has the least E value. So they also react with proton donors such as alcohol, gases ammonia, and the alkali. Reactivity towards the dihydrogen. The alkali metals react with the dihydrogen at about 600 to 73 Kelvin, lithium at 1073 Kelvin to form hydrides. All the alkali metal hydrides are ionic solids with high melting point. Means M react with the H2O forms MH, and that M can be lithium, sodium, potassium, rubidium, and cesium. Okay. Next is reactivity towards the halogen. The alkali metals react vigorously with the halogen to forms the ionic halides. That is M positive and that X. That X is the non-metal or the halogen family compound, and the M is the metal. So whenever this metal react with what? When this react with the X, these X. So when metal react with the halogens or this X, then what will form? That M positive and it's X negative, right? So with the exception of some lithium halides, there is an exception with lithium halides. So M will be lithium, sodium, potassium, etc., rubidium, cesium, and X can be fluorine, chlorine, bromine, and iodine. Then next we'll come to the reducing nature. Alkali metals are strong reducing agent. Lithium being the most, and sodium is being the least powerful. Okay, the alkali least powerful. M means solid to gas. The sublimation enthalpy is there. M metal when lose one electron and form ion and become a ion, then at that time the ionization enthalpy will be there. M positive plus H2O gives M positive, that is the hydration enthalpy. So alkali metals, these are the strong reducing agent and also least reducing, or कह सकते हो, that will be least powerful. Okay. Now solutions in liquid ammonia. Alkali metals dissolve in liquid ammonia and impart a deep blue color to the solution. Being ammonia is actually a colorless uh, liquid with pungent smell. We can find identify ammonia with its smell. Uh, or in our household work or day-to-day life, we used to feel ammonia in the coloring dyes, which we used to color our hairs. So generally, in old days, people used to color their hairs with the dyes. We used to smell some feel the pungent smell, and that smell is ammonia. Okay, so ammonia is being a colorless liquid with a pungent smell, and when alkali metals dissolve in that liquid ammonia, the color will change into deep blue. Okay, the color in the solution nature is due to the I- ammon- ammoniated electrons, which absorbs the energy in the visible region of the light and impart blue color to the solution. as you can see here. The solutions are paramagnetic and liberate hydrogen on the standing, which in turn result in the formation of amide. For example, this is the matter, this is the emanated electron, this is ammonia and forms MnH2 plus half H2. H2 gas get liberated. This where Am donate what is solution in ammonia. Am denotes the solution in ammonia. This is the Am. So the blue color in concentrated solution change to the bronze color and become diamagnet. Solubility. Next, next is like the blue color is due to the excitations of the ammoniated electron from high energy level and absorbs the photons occurs in the red region of the spectrum. Okay, we if we can say this thing that something is having color, something is possessing color, so that color is due to when the electron jump from lower energy state to higher energy state, it absorb that energy. Okay, after absorbing the energy, the electron will move from lower energy level to higher energy level, and when it come back to its original ground state, it liberate out energy in the form of the light, and that specific light has a specific color. That is why we used to see a different color of that compound at that time, right? Uses. Lithium metal is used to make useful alloys, for example with lead to make white metals, bearing to motor engines, with aluminium to make aircraft part, and with the magnesium to make the armor plate. It is used in thermonuclear reactions. These organoleptic compounds were earlier used in anti-knock additive to petrol, and nowadays vehicles are lead-free petrol. Liquid sodium is used as a coolant in the fast-breeding nuclear reactors. Potassium has a vital role in biological system. Potassium in our system digestion, and means potassium has the capability to transfer through our semi-permeable membrane, that is our skin. Okay, so it has a vital role in biological system. Potassium chloride is used as a fertilizer to increase the fertility of the soil. Potassium hydroxide is used in the manufacture of the soft soil. The potassium hydroxide is also used as an excellent absorbent of carbon dioxide. Cesium is used in devising the photoelectric effect. I've already told you this thing in solar panels. And so, what is photoelectric effect? When the electron means absorb light or photons, and it's just leave the vicinity of that atom and move out, that is photoelectric effect. And this property is used in the solar panels. So cesium metal is used in the solar panels because whenever the sunlight falls on the solar panel, the electron absorb that light, means because light moves in the form of small packets that are known as photons, and when these photons absorbed by that electron transfers this energy to that electron after absorbing that energy leave the vicinity of the matter. That is how the things get charged. That is how the solar panel work. So if someone asks you a question that which metal is used in the solar panels, that is cesium, because of its property, because of the loose electron, free electron.